I'm going to walk around a little bit too, and it's a small crowd, so if you guys want to move to this side, because I can probably move up to this pillar because of the camera. So if you guys want to kind of move a little here, it's better. Unless you want to sit there, that's fine too. I have a mic. So we're going to talk about immutable AWS deployments using Packer and Jenkins. So this talk is kind of more towards, DevOps side of things a little bit. So I'm going to do a show of hands just to make sure I have a level set as we go through the talk. But before we do that, a little bit about myself. So I'm Manish Pandit, and I work at Marqeta. It's a fintech startup based out of Oakland. I am the director of platform engineering there. So I am a developer at heart, but a DevOps guy at soul. So I've been kind of, I'm in that DMZ area, somewhere between engineering and DevOps, which I really love. And the way I'm looking at how cloud is evolving, in fact, the talk before this, Istio, a lot of that work was in that whole DevOps side of things, right? Because we write amazing code, but what makes it even more amazing is how we deploy it, right? And that matters, especially at the cloud scale at which everything is going now. So I'm on Twitter at lobster1234. Please, if you want to follow me, I do a lot of blog posts, mostly around AWS, some development stuff, some DevOps stuff, quite frequently. You can follow my blog. It's on GitHub. And then when you follow me, feel free to DM me or anything too if you have any questions, either about this talk or about anything which you want to talk about regarding AWS or anything like that. So show of hands, how many of you deal with deployments? Oh, good. We got a pretty curated crowd here. That's good. That's good. And then, is there any tooling involved in your deployments? Quite a bit, right? I mean, the days of SCP are gone. So we have DevOps, CI/CD, a lot of tooling in there. And then how many of you are deploying on Amazon? Good. What about the rest of you? Any other cloud providers, or pretty much it's either Amazon or private data center? That should be fine. You'll be able to relate a lot of these things to any other deployment platform which you have, which is the beauty of Packer. So what exactly is deployment? Deployment is essentially a process of pushing code beyond your development environment, right? We all love to code. We all write a lot of code. We stick it in Git. We do pull requests and do all the sweet stuff, right? But what happens after that? That is all deployment. Once the code has left your development environment, it goes into the deployment domain. And then deployments can be complete or they can be partial. And there is a fine line because how deep can you go when it comes to complete? By complete, what I mean is you build a server from ground up, that is complete. But what is the ground? Is the ground hardware? Is the ground operating system? Is the ground application server? Or is the ground a container, right? So we are going to talk about that. So how many of you, when you deploy code, are provisioning brand new stuff from scratch and then putting your code in there? So let's say I have V1 running, and to run V2, I build brand new infrastructure and associate that with my load balancer. Load balancer is the only thing which I'm not rebuilding, which, by the way, can change for blue-green testing, based on which approach you use, right? So, and then it can be partial. Partial is, I do a lot of Java stuff on the back end, and the deployment artifact is called a war file, right? Even in Scala, so when you use a Scalatra project, it spits out a war file, right? So because at the end of the day, you're going to deploy on a JVM container, which is pretty much like Tomcat or something like that. So partial deployment would mean that I'm just overwriting war files, right? Which seems pretty simple, pretty easy, right? So this is the example of the complete deployment. So you are provisioning the stack from ground up. There's MKFS, then you're going to mount it, and then you're going to install your applications in there, and then you're going to trigger it, right? So this kind of looks like complete, but then it's a lot of work right? Like every time I have to deploy a new version, especially if I am doing canary deployments or something like that, where I'm doing rolling deploys, this becomes pretty time consuming, even if I were to automate it quite a bit, because I'm doing everything from ground up, right? So partial is pretty common, it's, I admit it, I've done it for a good chunk of my career, and it just makes sense, All I need is a WAR file. Why do I need to care about installing a new Tomcat or installing like brand new operating system and stuff like that? Who cares, right? I have a server running, it's behind a load balancer. I'll get a little bit of downtime. Tomcat now supports on-the-fly hot deployments, right? So I just drop in the WAR file and it's going to work because we trust the developer who wrote Tomcat. So, and it's going to work, right? So we get this. So I refer to it as in-place deployment, because all you are doing is replacing the deployment artifact, which could be a WAR file in case of Scala and Java or any JVM-based frameworks, or it could be anything else. It could be an RPM for that matter. So it gives like a false sense of speed and agility that, hey, all I do is drop an artifact, we are good to go. So typical steps are like this. What I do is I SCP the WAR file to the production box, and then I SSH into it, and I bounce Tomcat. Good, right? Here, the problem is that now I have credentials to SSH into the production box. That's just one of many problems in this scenario, but this is like very typical partial deployment. Another example is that I get a little advanced, and I'm like, you know what, I'm not going to use SCP, I'm going to use wget and just grab the file. Instead of uploading it from my laptop, I'm going to take it a step further, and I'm going to get it from Nexus, right? Nexus or Artifactory, any kind of artifact repository, right? It's used for versioning and stuff like that. Since you guys do so much deployment and kind of DevOpsy things, it's pretty typical scenario, right? Your code gets checked into Git. It triggers a Jenkins job. That job runs tests. Once the tests are run, it plus ones the version. Then you cut a release. That release goes to Nexus, and then you have a deployment artifact, right? And then here, what I'm doing is I'm doing wget, and then I'm just doing a restart. Again, the same, pretty much kind of the similar things as previous one, except I'm not SCPing from my laptop. And then I want to do automation on this, right? Like how many wgets and SCPs I can do. So let me go ahead and automate this. So I'm going to script this all. I'm going to run it through a Jenkins job. And not only that, there is also frameworks to do exactly this. I've used Fabric in the past. It's a Python-based framework, which you can do to do exactly this. It just runs remote. So you can just say like remote wget or SCP this file, bounce Tomcat, remove temp folder and stuff like that, a lot of cleanup. So I've had some painful wounds from using Python, or not exactly Fabric, I'm sorry, not Python, Fabric, but it is, the wounds are not because of these frameworks, the wounds are because of immutable deployments. And there is Capistrano also. So what could go wrong, right? And these are the three examples of the exact same cluster which you deploy. In one case, let's say I'm deploying Jenkins itself. So in first case, it worked. And assuming that your load balancer health check is just TCP 22 or something like that, right? So if your health check is like /health check or something like that, best practice to tell the load balancer that your application is ready to serve traffic. This would not happen, but some symptom of this might still happen, like you could have a different version. So first example is it works fine. In the second case, looks like something happened. Maybe Tomcat didn't come up clean enough, or we don't know, right? And in the third case, the WAR just did not deploy at all. So Tomcat is up, but my application is not there. So something happened, right? And in order to troubleshoot this, what I'll do is, so these are like 3 servers behind a load balancer, one works, two do not. I will SSH into these boxes, and I'll go and I'll fix it a little bit. And then it's going to start working till it stops working again, right? This is an example of a highly mutable deployment, right? You can clearly see there. And then what I did was I put like these snowflakes in there. So you will hear this term a lot, snowflake servers, because every server looks different. I could be running Tomcat 8.5.11 on this and 8.5.13 on this, because I'm not touching it. Remember, it's in place. All I care about is my war file. And these are the symptoms which we run into. And these are classic symptoms. And you will start seeing this. Like every time you hit F5 on the browser, you'll see a different page or a different response. So unpatched, outdated dependencies. No one is taking a look at the operating system. No one is taking a look at CentOS or RHEL or whatever I'm running to make sure whether it is running the latest and greatest. Is it security patched? Is everything in there what it's supposed to be? Tomcat, what about CVE? Right? It's like vulnerability and exposures, I think, common vulnerabilities and exposures, CVE. So that is like a security list, which I think the government maintains. And you have to make sure that you don't end up like Equifax. So you have to make sure that your packages are there, they're deployed, right? So there's a maintenance side of things. No one cares about that. In-place deployment when we do. Inconsistent app behavior, like you saw in the previous slide. Changes outside of deployment cycle. What this means is that if something goes wrong, you just SSH in the box and install something in there just to troubleshoot, and then bounce the server. And that's it. Now you have made another snowflake out of this snowflake, because now it's entirely different than the other two, right? So you are increasing that delta between the servers, because for your customers, your load balancer is your interface. And it is a fair assumption that all the instances behind the load balancer behave the same way, right? And in case of partial deployments or mutable deployments, they do not. Human errors, right? How many times have we gone into in that SSH sudo mode and messed things up? I have a lot of times, right? So that increases the chances that I may have done something when last night I SSH'd into the box and I set up an agent which is filling up the log files and it's going to blow up tomorrow, right? So all of these things can happen. And this model does not scale. So when we are talking about rolling deploys, when we are talking about blue-green deploys, a lot of these like manual deployments, or even when you automate them to an extent, they are not exactly going to scale. So what is immutability, right? So immutability is pretty much an answer to all of this. So what this means is that we build the entire runtime infrastructure from ground up. And I kind of, if you remember a few minutes ago, I kept saying infrastructure from ground up, but let's qualify a little bit. Let's call it runtime infrastructure, because we are not going to kind of put a motherboard in place and mount hard drives and SSDs and stuff like that. So we are not going to do that. That infrastructure is there, but since that does not change often, like how many times will you upgrade the firmware of your SSD drives? Almost never, right? So let's leave that there. That's a fair assumption to make, that your hardware, underlying hardware doesn't change, your virtualization server does not change, but everything beyond up is what we are going to talk about here, right? So build the entire runtime infrastructure from ground up, right? And runtime, what do we call runtime as? It is operating system, all the libraries that you need, and I'd even go further and I'd say only the libraries that you need. App server, this could be Tomcat, this could be anything which you want, code, of course, the deployment artifact, and agents. The agent model is kind of, it defeats the purpose of using SSH anymore, right? You can have agents for Splunk, Elk, so you don't have to SSH into the box just to look at the logs. So you have log aggregators which do that. Performance monitoring, there's New Relic, there's Datadog. All of these come with agents. So you don't have to SSH into the box to find out how hot the CPU is, right? All of that is through agents. So ideally, you should not be using any SSH. And I'll cover it in one of my slides. It's like the immutable deployment nirvana is when you are no longer, where you can't even SSH into the instance. No matter, you could be super user, you could be admin, whatever, the AMI will, or the instance will not allow SSH. And once you're at a point where you do not need to SSH into the instance, then you know that you have reached that ultimate goal. So Amazon Web Services, since that's why I did the show of hands. So because it's really unfair to cover Amazon in one slide. So I'm going to still give it a shot. So basically, it is a collection of various services. This is the best definition of Amazon I could come up with, because it's huge. It is huge, and it's going to get huger in 2 weeks at reInvent. I'm sure they're going to announce a lot of stuff. I'm going to be there, by the way. I'm giving a talk there as well on the 27th. Look forward to seeing you there. If you guys are there, please hit me up on Twitter and we'll meet up. So compute, storage, database, messaging, this just scratches the surface of Amazon. And then it helps build architectures that are highly available, fault tolerant, scalable, and cost efficient based on how you use it, basically. If you're running like X large instances, then it's not cost efficient. But if you want to be cost efficient, it gives you a lot of options to do that. What are AMIs? How many of you are dealing with AMIs? So when you say you're dealing with, okay, good. So AMI is basically, think of it as an image. And that's what it is. It's Amazon machine image. So it is a template to launch EC2 instances. Now, for those of you who are developers as well, think of it as a class and an instance, right? A class is basically, it defines what an instance of this class would look like, right? It has methods and it has data. So it has state, and it has state is the data, and then it has functions to work on that data. So similarly, these AMIs are essentially templates. Which define, if I launch an instance using this AMI, what are those instance characteristics? Instance characteristics like what operating system is that instance going to be on? What is the virtualization type? So Amazon supports two, paravirtual and HVM. HVM is kind of preferred one, at least I prefer HVM. And looks like Amazon is also kind of moving heavily towards HVM over paravirtualized. Storage type, is it EBS backed? What kind of storage options you have there, or instance back, volume attachments, all of this stuff, right? And then it can be shared within accounts, and this is pretty cool. So in larger organizations, the way you organize your Amazon is that you have multiple accounts. You have a non-product account, a production account. Sometimes they create one account per org. So IT will have its own account, and engineering will have its own, right? So you can share AMIs between accounts, and they can be private. They can be even made public. There is an Amazon marketplace where there's a lot of AMIs you can go and buy. Those AMIs are pre-built with some servers and stuff, right? And then it is the highest level of deployment abstraction. So when we are talking about immutable deployments, we are going to talk about deploying the AMIs. Because the AMI defines that runtime infrastructure, which we talked about in the previous slide, right? So we are right we are not going rogue where we are doing in-place deployments. At the same time, we are not going hardcore where we are starting with provisioning a hardware on its own, right? This seems like a good balance of where we should be in terms of immutable deployments. So these are the AMIs on Amazon. This is Amazon Linux, by the way. So I have seen a lot of installations on CentOS. So CentOS has like not a similar list because this list is managed by Amazon. But if you go to launch an instance, you can see all there is SUSE, there is Ubuntu, there's everything there. But this is the list of Amazon AMIs. They patch it, release it pretty regularly, and you can see here that it has the AMIs are tied to a region. So you cannot use. You can copy them, but you cannot, if an AMI is tied to a region, you cannot launch an instance in another region using that region's AMI. So you have to move them across regions if you have to. So that's, and then you can see the virtualization type there. There is HVM, there is paravirtual, and based on what you want, there's an AMI ID. They get patched regularly and stuff like that, right? So what you do is you take this AMI. This is the base AMI from Amazon. It's Amazon Linux. Again, not tying this to Amazon Linux. You can use this, the same thing for CentOS or any Linux flavor that you want. Windows, I'm not too sure. Last time I used Windows was like 2000, I think. So not too sure about how the Windows world works, but it should be similar. There are Windows AMIs. Yeah.
Do you ever use CoreOS?
No. So mostly CentOS or Ubuntu. So what you do is you trim the fat, right? The AMI, the base AMI comes with a bunch of stuff, right? It's a generic AMI. So it will have SSH, it will have a whole bunch of libraries. So what you do is you start removing all those things, right? You don't need a VI editor. You don't need like Emacs. You don't need a whole lot of stuff which that AMI comes with because you are building a server. What you are building is a deployment artifact, right? You're not building like a desktop system, right? So what you do is you start trimming down the fat. And then you configure the libraries and tune the parameters of this based on what you need from this application or from this server, right? And then what you do is like, make infrastructure not var. That var is a Java reference. So this is what we'll do, right? So what helps us do this is something called Packer. And Packer is a tool from Hashicorp. Hashicorp is really, they have phenomenal products when it comes to DevOps and CI/CD and automation, stuff like that. Vagrant is from them. There is Consul. We use Consul at Marqeta for service discovery quite a bit. So Consul is also Hashicorp. There is Vault. There's a whole bunch of stuff coming out of Hashicorp. How many of you have used Packer in the past? You do? Perfect. So Packer is essentially a tool which lets you provision and also configure these AMIs to perform immutable deployments. And that is like one of the many tools from Hashicorp. If you guys have not looked at Hashicorp website, I strongly suggest check their products out. They are all open source as far as I know. And they are really, really useful. Like Vagrant and stuff like that, you will find a lot of value in Vagrant. We use Vagrant for a lot of our test environments, where we make sure that our test environments look exactly like our production environments and development environments. So Vagrant is good for that. Many, many tools. So we're going to talk about Packer in this talk. So it supports multiple providers, supports multiple provisioners. Now, what is a provider? So we are going to talk about provider, but installation is really straightforward. You can install it via Brew, or you can just download. It's just one file. It doesn't come as a package and everything like that. You just go and you just download it. It's just Packer. That's the command. It downloads as packer.zip and it explodes as Packer. So it's 1.1.1. I think probably this is the latest and greatest. And then what you need is, when you are going to use Packer for Amazon at least, and again, I'm trying to kind of keep the context to Amazon, but same is true for any other provider. You will need an EC2 role. And essentially, you're going to run it from your Jenkins server or wherever, and that server would need to talk to Amazon. So what you need to do is you need AMI credentials. Amazon credentials, IAM credentials, and those credentials will have a policy, IAM policy with them, because you want to make sure that you're not running this as admin user. You don't want to give it that much control, right? And then the details of that policy are available on the Packer website. And if you're running it from Amazon, you don't need to worry about credentials. You will rely on the IAM role to control Packer. So what are builders? So Packer has builders and provisioners, those two things. So what is a builder? So builder is basically, it defines machine images for multiple platforms, and it supports a lot of platforms. In fact, there are few in there I didn't even know existed. There was my first introduction to Ali Cloud. I had no idea Alibaba has a cloud too. I saw that listed in there, and I was like, what is this Ali Cloud? And I saw that, and boy, it's like awesome. It's really good coming up. So a lot of platforms are supported there. You can, if you use Docker, you're probably used to writing Docker files a lot. You can provision Docker containers using Packer as well. So you can have that uniformity in there, and you can version it and stuff like that, which generally with Docker files, it's a little complicated because Docker versioning relies heavily on the tags, versus here you can use the real version control. Popular AWS AMI, VMware, Docker, Azure, GCP, even VirtualBox. You can use the builders for that, and you can even do custom builders if you want to. So that framework exists. So this is what a builder looks like. This is a simple Packer template. So I've used the AMI ID for US East 1. I think, and then these are the variables. So it is going to either pick the variables from your credential file, or it is going to rely on the EC2 instance role if you're running this on an EC2 instance in Amazon. Okay, and then what I do is I specify what am I supposed to build here. So there is Amazon EBS. So Amazon has an instance-backed AMI and an EBS-backed AMI. And again, this talk will be too short if I go into details of that, and there's a few more. So Amazon EBS is pretty standard, pretty common. So we are going to use that type, but this type is a kind of drop down. It's a fixed list. And then access key and secret key. So this is I wrote this here because it shows how you can extract user variables, environment variables, and stuff like that within Packer. And then specify the region. Source AMI, this is the base AMI. So you'll see a lot of this base AMI term in there. So base AMI is AMI which you start with, right? It's a chicken and egg problem. You have to start somewhere. So base AMI is the one which is published at Amazon, which you'll take and you'll customize. And then instance type is T2 micro. So this instance doesn't mean that you can only create T2 micros once I create an AMI. What it means is that the way Packer creates an AMI for you using this AMI, it needs to launch an instance, it needs to take your instructions, and then what it does is it snapshots that instance to build your AMI. We'll see that in the steps. But this is just to tell Packer that, hey, when you launch an instance using this AMI ID, use a T2 micro. And for my usage, I found T2 micro to be perfectly fine. You don't need anything bigger than that. SSH username, so since this is an Amazon Linux, it is EC2 user. For Ubuntu, it'd be Ubuntu. But generally, this is like, don't worry about it. It's EC2 user for Amazon. And the AMI name. So this is the custom name I gave it. Scale by the way AMI. And then what you do is there is an option to inspect this JSON. So it catches any syntax errors or anything like that which you have. It tells you what it found. It found the builder as Amazon EBS, and there's no provisioner. Provisioner is something we'll talk about soon. And then this is where you build it. So building is the interesting part, right? So what it is doing is that it found the image, right? And then it was waiting for the instance, because this is where it is launching a T2 micro using that instance ID, using that AMI ID. So it has launched that instance now. And then what it does is it waits for SSH to be ready. By the way, this output is huge. I've just pasted like a snippet of it, but it is very verbose. It tells you everything which it is doing. And then it creates, and then it tries to SSH. The reason it needs to do an SSH on that box is to run your provisioners. This definition which I did, it's just like hello world for Packer. There are no provisioners there. What it'll do is that it'll be a copy of that Amazon's AMI, right? The only thing is that it'll become private to your own account, and we'll see that. So waiting for the AMI to be ready, and then once the AMI is ready, it creates a security group also, and that security group will allow SSH access from your account to that, from your IP to that AMI which came up, so it can run provisioners, because in order to SSH, it needs the security group to be able to get into that, right? So you have to make sure that if you're launching all this in a private VPC, you have a NAT gateway or internet gateway connected to it. So those are the kind of things you have to look at. And then basically it is done, and then it created this AMI. So what it did was it launched an instance and took a snapshot. That's probably the only way I know of creating an AMI on Amazon is that you snapshot an instance. So this is what it did, right? And it created this AMI ID. And then you can see it. So if you go to the AWS console, you can see that ID here. So I created it. It's an HVM, and the name is Scale by the way AMI. I've removed the account ID, but this is where the account ID shows up. Okay? And I'm the owner. I removed that ID also. And then you can see it here. So when I say like I need to launch an instance, that AMI shows up, right? And the only thing is, that you have to make sure that you click here, owned by me. So you're not looking for this AMI in a big list, right? So we filter this out, and you can see it here, right? But the thing is, like, we have an AMI, that's it, right? How does that solve the immutable deployments problem? We just created an AMI. We didn't do anything else with it, right? So in order to do that, we need to provision stuff on it. And by provision, I mean we need to make it useful to us, right? And we can make it useful to us by installing application servers on it, by doing something with it, right? And the standard way to configure machines or AMIs or VMs or any kind of like operating system level raw virtual server is to run, either Ansible or Chef or Puppet, or we can just run shell scripts, right? And that's what we'll use for this talk. But you can use all of these provisioners. So Packer supports all of these provisioners, and then there is more. Just like the providers, I was surprised, or the builders, I was surprised to see how many exist. There's something called Salt 2, which I've never heard of. Yeah? That's what I was. Oh, about Salt? Yeah. So I never ran into Salt before running into Packer. I'll check it out, definitely. So there is shell, of course. So we have to make our AMI useful. Now, how do we make it useful? We apply patches. We'll install OpenJDK, install Tomcat, download the war file from Nexus, and then configure Tomcat to run at the startup. So once I have burnt all of these things in the AMI, and I launch that AMI, it launches pretty quickly. Why? Because I'm I'm not bringing the AMI up or bringing the instance up, then running a startup script. And some people do that. I've done that a few years ago, where you configure the startup script. So in Amazon EC2, there is an option. There is a startup script. I forgot what the technical name for that is, but there is basically a binary script which you can stick in there, which runs at instant startup. So what you do is you can run your Chef, or you can run your shell scripts and all of that stuff at the startup. But the problem there is that now you have a base AMI, and then you are installing Java, you're installing Tomcat, you are installing whatever runtime you want. Again, I keep talking about Java, but same thing for Python or anything else. You are installing a runtime, your application server, and stuff like that. And then, so if you're running in an auto-scaling group, where how many of you use auto-scaling groups on Amazon? Yep. So when you get a lot of traffic, your ASG, auto-scaling group, auto-scales, which means it launches more instances which look exactly the same. So imagine, right, when you are hitting a lot of traffic, and you are launching an instance which is still installing Java and Tomcat, and meanwhile you are getting bombarded with traffic, right? So it's not worth it, right? So by doing all of this, by provisioning all of your runtime infrastructure in the AMI, you are saving all that time. So your AMIs or your instances, when they are launched, they are ready to take traffic right away without waiting for a lot of provisioning. There is nothing to provision once everything is provisioned in the AMI. Yeah? Do you register your services with something like Zookeeper? Yes, we do that with console. Okay. Yeah. Definitely you can, and that's a good strategy. But a lot of times what happens is that you're running behind a load balancer. So essentially all your instances are behind that load balancer, and that load balancer is the interface to the external world. But yes, you can use console. And there is like a post-provisioner scripts. I'm not covering that in this talk, but there is post-provision scripts where you can do that. We do have Lambdas, but not Spot instances. Yeah. So let's provision the AMI. So here, I'm using shell, right? Because I thought, some of the audience knows Puppet, some of the audience knows Chef. Everyone knows shell, right? So there's like the common ground we all agree on. Even though in the real world, you would use something more professional than shell. So this is the shell, and the reason I use shell is just to give you an overview of what I'm doing here. So remember, like we had a builder snippet, and this is a provisioner snippet. There can be multiple provisioners. You can mix and match. This is an array. Provisioners is an array, so you can have multiple of them. You don't have to I started with shell, now I want to do Puppet. Yes, you can. So what we do is we do yum update -y, obviously, sudo yum install. So I'm installing OpenJDK and Tomcat. And then I'm removing Java 7. And then I'm doing a wget. Now again, this is like a little crude because I have a Hello World project on my GitHub, and I created an artifact for demo purposes. And then this is what it is doing is that it's downloading this. In the real world, this would be an artifact from your Nexus. And in the real world, you would pass version as an environment variable or a command line argument, right? So now when I'm creating an AMI, and then I'm doing a gunzip, so this goes in the war file, and then I'm making sure Tomcat comes back up every time I launch an instance. So boom. I have now nothing else to do in my application, right? All I do is I launch this AMI and I got everything I need, right? And this is what's going on. So I changed the AMI name to with Tomcat, and then I have a provisioner. So this is something which you had in the previous slides, and we also have provisioners here, right? So we added that provisioner, and it did the same thing, except that this time it went through the whole Java, Tomcat, and GitHub and everything in there, and then it built this AMI 73ED5509. We can see it there. So now I have two AMIs. One is without Tomcat, one is with Tomcat, with my application in there. And then I can launch an instance with it, and we can check it out. So we can see here, where's the AMI name? Come on. This is the instance. Yeah, there you go. So AMI ID is with Tomcat 8. And then I can go and I can check it out. And it did bring up my Tomcat. By the way, I do not recommend this in the real world. In the real world, this page should not show up when you're deploying Tomcat. But this is a talk. So you can see that Tomcat comes up, and we deployed a WAR file, right? So that WAR file has an API in there called hello world. We are going to hit that API right here. So what I do is I do a curl on the same address /hello world -API /hello, and I get the response hello world, right? So now what did we do, right? We did not deploy any code at build time or anything. We have an AMI. I can deploy as many instances of this AMI, and I'll keep getting this. If I have a new version of hello world 2.0, I can use that version to now, basically do immutable deployments. Now there is no conflict between versions or anything else, right? And you automate this whole process, right? Basically, this is what a Jenkins job would look like. So you'll do all these steps, except you'll do them in Jenkins, right? So this is the summary of this talk, is right. Do not release code, release infrastructure. And this is important, right? You write code, but release infrastructure. You do not release code. And automate everything. And obviously, legendary mode is when you do not need to do SSH on your instances at all, right? These are the resources. So this Packer site, EC2, and then I have a blog post which covers all of this, including the Jenkins job, and there is a gist and everything in there. Tiny URL, Packer -Jenkins. You can go there, or you can go to lobster1234.github.io. That's where I have a blog post about this. And then if you have any questions, if you like what you saw, this is what you'll be working on at Marqeta. So this and much more. So any questions, please let me know, and then follow me on Twitter. You can DM me as well, and that's my blog. Questions. This is all I had. Questions I can help answer. Which one? The summary?
Yeah.
Or resources?
Resources.
Yeah.
If there are any questions, I can come around with the mic.
I think.
Yep.
Yeah.
So do you have SSH disabled on your server?
Right now we do not. We still have SSH. What we are trying to do is we are trying to minimize the times we have to SSH. So we use Elk. So a lot of our logs are on Elk, and we use Datadog as well as New Relic. So very rarely we have to go to SSH on the boxes, but hey, we are using Packer. So that's the good part. So we are trying to see how less do we need to SSH. So far, we have not had to. There is only a few instances, and the example would be a log file which we are not ingesting in Elk because that's relatively new. But then that's the change we do in the next AMI. Yeah. Yeah.
So can you comment on the cloud formation versus Packer?
That's a good question. So cloud formation, again, the way I would think cloud formation to be much more advanced. Cloud formation I would use to provision things beyond AMI. Things like auto scaling groups, things like queues, things like SNS topics. So any kind of Amazon resources, I would use CloudFormation. But any application or deployment related resources, I'd use Packer. So that's how I would distinguish between CloudFormation and this. Same with serverless, right? I use serverless framework over CloudFormation. And again, because serverless framework, I find it to be much more friendly than CloudFormation. But yeah, to answer your question, definitely CloudFormation I would use for Amazon resources. And for that, by the way, we use Terraform. And that is also from Hashicorp. So yeah,
How long have you been using Terraform?
about a year.
Okay.
Yeah.
I was looking.
It is really good, really good. Yeah. Yeah.
Can Packer create launch configurations as well, or does it just create the AMIs?
It only creates AMIs. So launch configurations, you have CloudFormation to do that, or Terraform. We use Terraform for launch configs. Yeah.
So with this, is it valid to, after you deploy to AWS, just take an AWS snapshot image and just use that after that? Afterward, does it always use that?
Yeah. So there is like multi-step. So there is snapshot, and then that snapshot is to be registered as an AMI. So those steps are there. So if you were to get rid of this, then you can go and you can go to the AMIs page and deregister this AMI, and it will no longer be available. Yeah.
Is there a good resource for like services and libraries you want to strip away from a standard AMI, like on Ubuntu AMI, or like, do you have a list of like where like, hey, these typically are installed instead of having to search?
Yeah, that's a good question. I did not find anything.
CoreOS.
Yeah, CoreOS is the bare minimum, right?
Yeah.
Yeah. We haven't looked into CoreOS yet, but definitely I'd take a look at it, because that is really good point, where you want to start with bare minimum and build on top of it, versus start with something which is a little fatty and then try to find out what I can get rid of. Like, I don't need Ruby for anything, so let me get rid of Ruby. But like, I'm doing a lot of guesswork, and again,
Chef, right? If you use Chef.
yeah, exactly. If you use Chef, then you are tied to Ruby, because if you're using a Chef provisioner. So stuff like that. A lot of guesswork, a lot of human intuition and stuff comes in. Any other questions, folks?
What is the costs attributed to having storing these custom AMIs?
You do have storage cost for the AMI, but because that EBS snapshot, you are paying by the hour for the EC2 storage, EBS storage, and then you will pay the cost of the instance uptime when you launch the instance. But when you are running Packer, the instance comes up, it gets snapshotted, and the instance is shut down, so you're only paying for the snapshot storage.
There's also Atlas, right? Like
Atlas is also
you can
Hashicorp.
store your-
Yes. Yep, you can use that repository. Atlas is like a repository.
It's less expensive, right?
I think so, yeah.
All right, why don't we thank Manish one more time?
Thank you so much, yeah.
Get ourselves finished.
Thank you, everyone. It was great talking to you guys. Thank you. And then